If you're not familiar with p-brane, he is a self-proclaimed perspective expert. So we're going to take a look in this video to see if this is true. Is he really a perspective expert, or are his claims just perspective fallacies? Now this is a video from 2015, and let's listen to p-brane explain the perspective matrix.
If in fact, and they do, they converge at your eye level horizon visually, then it makes sense that after that point they diverge, meaning they then separate, so the sun would continue on a downward track.
Now wait a minute, you're saying this makes sense? So I have a question. If you claim that this is why the sun continues down, then why doesn't the ground continue up? And are you going to tell me that train tracks and telephone poles diverge after the horizon? I think one of the problems flat earthers have is that they are always using these side perspective views like down below with converging parallel lines to explain what we really see up above. So here we have a row of telephone poles. So exactly why do they appear to converge in the distance? So this is a simple scale diagram. Let's say we have 4 poles. They're all spaced 10 feet apart and they are 16 feet tall, and the observer's eye level is right in the middle at 8 feet. Now this is how big in angular size the first pole appears to him. The top of the pole enters his eye at this angle, the bottom enters at this angle. Now the second pole is 2 times the distance, but you can see that it appears to be 1/2 the size of the first pole. The third pole is 3 times the distance, so it appears to be 1/3 the size. And of course the fourth pole is 4 times the distance, so it appears to be 1/4 the size. Now look at this, look how high the ground appears compared to this first pole. But he does not see the ground rising up because he has depth perception. He just sees that as being farther away, a flat surface. And the opposite happens on the upper side. So the reason these appear to get smaller and smaller and smaller is because these visual angles are converging towards the observer's eye level. Now if these poles went far enough away into the distance, they would converge to the vanishing point. And this is why we see this. Sorry, but this is made up nonsense. So here's a video from 2017, and let's listen to p-brane explain a horizon on a flat earth.
And what will happen is ball earthers will say, oh, you can't see the bottom ground level of the building, therefore it's curvature. No, what happens is if you can't see any more ground due to perspective, like I've just showed you here, that the ground and the sky meet, and you can't see any more ground, what if an object is sitting 10 feet behind that horizon? Well, we know for a fact, based on this, you're not going to see the ground. That's for sure. So if you're not going to see the ground, then there's a chance you're not going to, and this is logical progression, there's a chance you're not going to see a little bit of the bottom of the object that's sitting on the ground either, depending on how far away it is or how far beyond the horizon the object is.
Amazing. So now perspective can make land magically drop right off after the horizon, and this is why we don't see the bottom of this distant building. And as the building gets farther away and smaller, then it hides more of that building. You know, you were correct that you do not see the land beyond the horizon, but wouldn't that land just be merged into the horizon? Wouldn't this diagram be a better representation of the flat earth? I mean, I'm sorry, again, this is made up nonsense. And you know what? This looks quite familiar. Isn't this really the globe model? So aren't you really using the globe model to explain how the flat earth works? Well, here we go to 2017. This is real science for a shifting paradigm, flat earth. Now there are 5 topics in this video, but I'm just going to cover the first and the fourth one. So let's listen to a close sun.
The sun is close, about 3 miles away. How do I make that claim? Well, I make that claim because of these convergence lines, right? Everything converges at the eye level of an observer standing on the ground. So for the average height person, it's about 3 miles out. All these lines converge.
Yes, we are in agreement of parallel lines appear to converge in the distance, but why do you assume they would all converge at the horizon?
Okay, now where in relation to the observer or his body, where does this convergence happen? Well, it happens at the observer's eye position. In this case, it's the eye level of the observer. So in this picture, we have the ground or the water ramping up following the convergence angle. And when the ramping ground plane intersects with one's eye height, that's when one's horizon is formed. You can see objects beyond your horizon, but you can't see any more ground at that point. And
Now wait a minute, you correctly say that you can see objects beyond the horizon, but you have a diagram where everything including the building is converging to the horizon. So which one is it? Because you're contradicting yourself.
here's the crazy part. Visually, clouds, sun, moon, stars, airplanes, everything would go then to your horizon because that's where the convergence point is. That's where it would visually go from your perspective. Now, when I say visually, I don't mean some visual apparition or some kind of illusion, optical illusion, so much as I just mean perspective and convergence, right? Perspective convergence.
You know, I don't understand why you never try to draw a scale drawing to understand how things really work. Here we have a jet flying 6 miles above the Earth. It flies at 600 miles an hour. That means in 1 minute it has traveled 10 miles. If you're the observer here, this is the visual angle to that jet. But here is your 3-mile horizon. Do you already see the disconnect? But you claim that everything visually converges at the horizon, with diagrams showing everything dive bombing right into that horizon. Yes, this jet would eventually appear to converge at the horizon, but visually the jet would be well beyond that horizon because this parallel line is high. It would take a long time for it to converge. And then you even have the sun coming in at a steeper angle. No, it would take that sun a lot longer past the horizon to converge at the horizon. I'm sorry, but this is just more made-up nonsense.
Well, again, the convergence lines are the key. In order for convergence lines to all converge at one point, and these are the horizontal lines that are stacked up. They're kind of stacked up on your vertical axis, but they're horizontal lines. The only way they can all point at the same place is each higher one has to progressively angle more and more downward as it goes away from you, right? So that's how it visually all go to the same place. So the sun is on one of those lines. The clouds, the sun, moon, and stars will all go down into the ground.
Now this is the problem trying to analyze this on a two-dimensional photograph because there is absolutely no depth perception. So on this photograph on the right, yes, these lines look like they're just short lines angling down to the same point. But this would be a little bit better representation because we know we see objects beyond the horizon. And of course, the higher that object is, the farther beyond the horizon it is going to be before it converges to the horizon.
From your perspective, they're going into the ground, even though they're parallel lines, right? But they're converging. And you're not going to see them. They're going to sink into the ground. And that's exactly what the sun, moon, and stars do. Look at them. They're angled into the ground. What are they going to do? Are they going to all of a sudden hit eye level and straighten out? No, they continue down into the ground as we witness with the sun, moon, and stars. That is your flat earth celestial perspective. That is your perspective matrix at work right there.
So this is where I do agree with p-brane because this is exactly what we see. We see a sun setting and that angle goes right into the ground. And like p-brane says, it just can't come down to the horizon and change direction. But I don't understand how this makes logical sense to p-brane, because he claims he lives on a flat Earth where everything converges to the horizon, but then he goes, sun, yep, goes right into the ground. Now this is a screenshot from my video, a question for Eric Dubay and Phuket Word on this very topic. And Phuket Word actually recorded this video. Look at this sun. It is almost perpendicular to the horizon. I live in Thailand. This is exactly what we see. And if you live in the tropics, you know that the days average between 11.5, 12.5 hours per year. So at sunset, that sun has about 12 hours to get back to the east to rise. Like p-brane says, the sun just can't go down, suddenly turn right and head around the North Pole. So how does it get back to the east? It goes right underneath me. But of course, for p-brane and other flat earthers, this makes no logical sense. You know, when p-brane talked about the perspective convergence, I think the word that he was really looking for was Flerspective. And this is when flat earthers use perspective as an excuse to explain away anything. So I'm sorry, p-brane, your perspective matrix is Flerspective. Your horizon that drops off is Flerspective. This diagram with everything 3 miles out is Flerspective. And when you admit that the sun path goes right into the ground, but you think this is explained by parallel lines that should converge at the horizon, Flerspective. So sorry, p-brane, you are absolutely clueless as to how perspective really works. But I will give you some credit. You are an expert in Flerspective.